Okay, constant multiples. So this is when you have a function times a c in front of it. So if you have like c times a function f of x, and let's say you're doing a derivative. So the notation we'll use is we'll put a bracket around that and just stick a prime on the bracket. Okay, in English we're saying the derivative, oopsie daisy, the derivative of this guy. So the constant multiple rule says, let me clean this up for you. It says that if you have c times a function, so c is like a 7 or a 6 or a -3. If you have c times a function and you do a derivative, what you can do is you can take the c out front. Oops. Sorry, let me just write the prime on the square bracket. And that'll, of course, be c f prime of x. So an example here, let's do a little example here. If I have 6 times x cubed, and I do a prime, what happens? I get 6 and then x cubed prime. So my constant multiple says the 6 can come out. And then I have 6 times the derivative of x cubed. Now the derivative of x cubed is, we'll use our formula up here. You just descend to the 3 and subtract 1 from the exponent. And then I do 3 times 6 to get 18 x squared. Sums and differences. We'll do these at the same time. Pretty straightforward. If you have a function plus a function, so f plus g, and you prime, then you can do a distribution of the prime. Oops, I got a typo here. F prime of x plus g prime of x. So there's my formula. My constant multiple formula is here. And if you have difference, it's the same idea. You have fx minus g of x, and you prime, and then you'll have f prime of x minus g prime of x. Okay, let's do a significant example over here. So if I have, say, x to the 4 minus 2x to the 5 plus 7, and I prime that, then I'm going to get the prime applying to all 3 parts separately. Okay, the first one I use my power rule. So the power rule is, again, the exponent comes down, and then you subtract 1 from the exponent. My 2 can come out front here, leaving x to the 5 being primed. The derivative of 7 is 0. This is my first rule I gave, the constant rule, where the derivative of a constant is 0. Okay, last thing I need to do is do the derivative of x to the 5. And that'll be 4x cubed minus 2 times, now the 5 comes down. I subtract 1 from the exponent. And that's that. My last step will be just to clean this up. I get 4x cubed minus 10x 4. Okay, last one. Exponential functions base e. This is perhaps the easiest one. It says that if you have e to the x and you do a derivative, then it does not change. So this is very nice. You do nothing. And in fact, our textbook defines the base e, it defines the number e actually. It defines the number e. You can define that in more than one way, but our definition is that e will be the number that makes this formula true. Okay, so it is the unique base such that e to the x, when you take a derivative, gives just e to the x. So if you do 2 to the x and you do a derivative, you are going to get something different, but we'll see that later.